Good morning, everyone. Welcome to the webinar on the Caribbean coral maps, revealing the world beneath the waves of Puerto Rico and the United States Virgin Islands. Thank you for joining us today. My name is Jimena Escobar Fadul. I am the Coral Strategy Manager for the Nature Conservancy in the Caribbean, and I will be the host for today's webinar. This webinar was organized by the Nature Conservancy and the Department of Natural and Environmental Resources of Puerto Rico, or DNER. TNC is a global nonprofit organization dedicated to conserve the lands and water of which all life depends. We work in 17 countries and territories across the Caribbean region. Today, we will be presenting some of our work related to mapping marine benthic habitats across the region. This work will be presented by Dr. Steve Schill, which is TNC's Caribbean Division Lead Scientist. We would like to thank the Department of Natural and Environmental Resources of Puerto Rico for co-sponsoring this webinar with us today. Special thanks to Astrid Green and Ingrid Flores Vallejo, both with the Auxiliary Secretariat of Education and Community Relations of DNER. Next slide, Ingrid. So I would like to go over some housekeeping before we get started. So today's webinar will be recorded, and we will be sharing this recording with you by the end of the session. I would like to ask you to please keep your microphones muted at all times, exceptions when you're going to be asking questions at the end of the session. And we ask you to put your camera off in case there are bandwidth issues. You can do this at either at the top of your screen or at the bottom of your screen. There should be a camera and microphone icon to do this. So we have organized this webinar like that. At the end of the session, we will have a lot of time for questions. And so if you have any questions, there are two ways to do this. You could either type your questions into the chat, or you can raise the hand, and then we'll give you the voice at the end of the session for you to ask your question. You can ask your question in Spanish or English if preferred, then we will do the best to translate if it's in Spanish for the presenters. So now, after these housekeeping items, I would like to turn the floor and give it to Alberto Mercado Vargas, Puerto Rico Program Manager of the Nature Conservancy, who is going to give an introduction and welcome, and then to Celeste Jarvis, USVI Director of the Nature Conservancy, who is going to do the same. Alberto?
Oh, thank you, Jimena, and thanks to everyone for joining us. TNC in Puerto Rico is working since 2011, and our main projects are focused on the conservation of coral reef, fisheries, and marine resources. We are working closely with DNER, the NOAA Coral Reef Conservation Program, in several initiatives that included, but are not limited to, supporting DNER in their jurisdictional priorities. I am happy to share more information about our program after this webinar. We will post my contact information at the end of the event, so please welcome and enjoy the presentation, and remember that in TNC we are open to collaborate. So thanks, Jimena.
Thank you, Alberto. Celeste?
Yes, my name is Celeste Jarvis. I'm the Nature Conservancy's director for the Virgin Islands program. I was raised in St. Croix, which led me to become an environmental scientist, but I spent much of my career in supporting NASA and NOAA to build satellite systems that look back at the Earth and interpret their data. So this is a topic that is near and dear to me. The Virgin Islands program conducts a wide range of activities in the Virgin Islands. We have preserved over 700 acres of land in the Virgin Islands, and we also helped to establish the St. Croix and the St. Thomas Marine Parks that set aside and protected 53 square miles of nearshore waters. Our most recent developments have been in the area of coral restoration. We have developed a coral innovation hub with a land-based nursery with 28 raceways, in addition to multiple in-water nurseries. And this will allow us to begin to restore the reefs in the Virgin Islands. The mapping tools that you will learn about more today was instrumental in helping us to locate the best locations for coral restoration. And that has led to TNC securing a $2.2 million grant from NIFWIF. And this will help us to begin restoring reefs in the Virgin Islands on a large scale. With that, I'd like to introduce Dr. Steve Schill. Dr. Schill is the lead scientist for the Nature Conservancy's Caribbean Division. As a marine conservation specialist, he has been promoting the use of technology to protect and manage marine resources for over 15 years. His expertise includes remote sensing of marine habitats, systematic design of marine spatial plans, and the development of a GIS-based decision support tools. His team works with governments and partners to map marine habitats and model ecosystem services, strategically expand marine protected areas, and develop new monitoring techniques. Recently, he's been involved in developing multi-scale approaches for monitoring coral reefs and mangroves using satellite imagery as well as aerial and surface drone platforms. Steve received his doctorate in geography from the University of South Carolina and is an adjunct professor in the Department of Geography at Brigham Young University. Steve?
Hey, thanks Celeste, for that introduction. Today, yeah, we're going to dive into these new maps that the Nature Conservancy has been working on. I want to thank thank Jimena and Ingrid and Alberto and others for organizing this. So our main goal is to get these new benthic maps out into the hands of users, and these maps were created for the entire Caribbean, the insular Caribbean, and I'm going to talk about the techniques and some of the limitations of the satellite that we used. This project, we've been trying to map shallow benthic habitats since the early days when I started working with the Nature Conservancy, and that was back in 2003, where we did an ecoregional assessment of the entire region. And at that time, the best coral reef maps that we had were the millennial reef maps. They were just coming out, and it was the first attempt to create a global map of coral reefs using the Landsat mosaic that had just been finished based on 2000 Landsat 7 data, and so we use that, and as we use those global data sets, we quickly realized the limitations of using a 30-meter pixel, and we were not resolving a lot of the smaller patch reefs, because in order to map reefs with a Landsat sensor, the smallest thing you can map is double the pixel size. So that means that in order to pick it up on the Landsat scene, it had to be at least 60 meters in dimension, in its smallest dimension. And so all those reefs that were smaller than that, and we know there are a lot of them, were not being mapped. They just can't be resolved with that Landsat. And so we started to use higher spatial resolutions for different projects where we received funding. We did a lot of, thanks for advancing that. We started doing projects in the Eastern Caribbean, mapping with satellites like WorldView 2, which can resolve at 2-meter resolution. We used a lot of Pleiad, and this produced a lot better results. And we could start to get a better idea of the footprint of the coral reefs. So I wanted to just introduce that topic, that the global reef products can only take you so far, and for small island states that we work in, we needed some better data to be able to get a better idea of where these reefs are. So that slowly we mapped country by country, and we've mapped quite a few, but we've always had this vision of being able to do the entire Caribbean consistently using the same satellite, and to be able to afford it, because the WorldView 2 and the Maxar, the Airbus imagery is expensive. And so in 2005, or I'm sorry, in 2015, there was a company started called Planet, and they put the remote sensing world kind of upside down by coming up with this idea of, let's get these very small satellites and let's make them more efficient. Let's put them up in space in a sun synchronous orbit. They're all lined up, and they had the goal of mapping the entire planet every day, and that's something that had never been done. And these satellites could resolve at a 3.7 meter resolution. It's variable depending on the height of the constellation, but they did this in a period of 2 years, which was amazing. And so we took the opportunity to talk with them, and along with the Allen Coral Atlas, we approached them kind of at the same time, and we worked together to get the satellite data. And I'm going to talk about the process that it took to take thousands of these satellite scenes and mosaic them together, and then come up with a final product that was a consistently mapped benthic habitat product across the whole Caribbean. So let's that's kind of an introduction. So let's go ahead and dive in. So what you're seeing here is the Planet Dove imagery, which I'm going to talk more about. And in the middle slide, you can see that those millennial reef maps, what was mapped from the Landsat mosaic of 2000. And a lot of these were photo interpreted, but they overpredict a lot of reef in some area, and they really miss patch reef. So if a country has very broad reef coverage, it will do a good job. But if a country has a lot of those small patch reefs, it's going to underestimate, like the Bahamas. And that's what we saw when we compared the areas of the Bahamas, is that we mapped a lot more reef than the millennial reef maps showed. So, and then what you're seeing on that far right is the final output with the 13 classes, and you can see the difference. We're also mapping not only reef, but we're mapping seagrass as well, and the hard bottom habitats. So next slide. So we're really focused on understanding coral reefs at different scales, because at each scale there's insight that you can gain, and together they make up the big picture of what's going on in coral reefs. So at the satellite scale, space-based imaging, we can map large areas, and depending on the satellite, you have a larger footprint, but the spatial resolution is not as good as obviously a diver underwater. We can use airborne platforms, and that provides the opportunity to attach different sensors. We've done some work in USVI and Dominican Republic with Greg Asner with his Global Airborne Observatory, being able to map things like percent live coral, which is something that you can't do with satellites. And obviously this is very much integrated with field data to be able to get the results that you need and the accuracy levels that you want to get. With aerial drones, we can monitor small areas at centimeter level, and then there's a lot of work and growing research in structure from motion, using cameras and collecting stereo photos of the reef 2 meters above the reef, where you get very, very high resolution, and then you process that with photogrammetry software to come up with very high resolution orthomosaics and digital surface models. And the combination of all these really gives you a good information, a good monitoring strategy for coral reefs, because at each scale it answers different questions. Let's go to the next slide. So the Dove satellites, here's an example of one. There's hundreds of these that have been launched. The next generation are called the Super Doves, and those are the ones that are being launched a few weeks ago. There were 43 that were launched, and they have better capabilities. But the ones that we've been using are images that were collected from 2017 to 2019, and these represent the mosaic that we created represents over 38,000 individual scenes, because each scene is about 7 by 20 kilometers in dimension, and so it takes many of them to be able to cover an entire place like the insular Caribbean. And we had to go through the advantage of these satellites is that they collect images every day, and so you can choose the best images that have a clear water column, low turbidity, low sun glint, and we had to go through and choose the best images to be able to piece these together. Planet is the company that operates them, and they have an automated algorithm that goes through and picks scenes based on cloud cover, but when you're looking through the water column, you want to look at things like low sun glint and low turbidity, and so we had to go through and fine-tune that. But these are very small, the size of a toaster, and they pack a lot of electronics in these. They have 4 bands. Let's go to the next slide. So you can see the 4 bands here: blue, green, red, and near infrared. The near infrared we used to be able to deglint the imagery. That was really important, but these are very broad bands. The signal to noise ratio is pretty low. That means that essentially the radiometric quality, or the signal that we're receiving, doesn't have as high a fidelity as a sensor like WorldView 2 or WorldView 3, which are satellites that are the size of a bus and cost exponentially more to build and launch than these satellites. So, but the advantage that the Dove satellites have is that they're collecting on a daily basis, and so the temporal resolution is very high, and you have the ability to choose the best images where you can see through the water. Let's go to the next slide. So here's an example of the mosaic and the process we had to go through to get rid of the seam lines. And you can imagine, if you have thousands of satellite scenes that are all collected on different days, different atmospheric conditions, the sun is different position, you're going to get seam lines. And so we had to use what's called a color target to go through and try to balance and normalize these scenes and remove the seam lines. And so you can see in A what we started out with, and D was the final manual QC, where we applied a color target and we used the MODIS sensor with a very broad footprint to be able to balance across the scenes and try to equalize them so that you had a seamless product. And Planet has developed this algorithm in cooperation with Greg Asner's team, and it works very well. At the beginning, they were mostly focused on land-based mapping, and their algorithm wasn't very good for ocean studies, but through this process, they've really fine-tuned and developed a normalization and seam line removal algorithm that does a very good job, as you can see here. So next slide. So here's the final mosaic, over 38,000 scenes, 16 terabyte mosaic that was all put together and color balanced. We actually created products, benthic products, for the whole Caribbean basin, but we spent particular attention in the insular Caribbean, where we did a lot of manual correction. I'll talk a lot about that. Next slide. At the same time, we had to develop a geomorphic zone map, and that was used in developing the rules to map different benthic features, such as seagrass, which largely occurs in these sheltered lagoon areas. And so we hired a team to use the high-resolution base maps in Google Earth and Microsoft Bing to go through and manually digitize these. And that really helped in guiding the selection of where these different benthic habitats were. And you can see things like the shelf, the forereef area, the reef crest, and then the lagoon. And this is an example in eastern Grand Cayman. And we did this for the whole insular Caribbean. Next slide. And if we zoom in, we can kind of see, this is looking at the Planet Dove data. You can see that reef crest there with the fore and the back reef. And then extending deeper into the ocean, you can see the spur and groove. And that was easily recognized, and that was mapped and manually edited for precision. I'm a firm believer that you've got to have some kind of manual intervention to be able to get the accuracy that you need in a lot of these products, especially when you're dealing with a sensor like Planet, which has a low signal to noise ratio. And so we did that, and that's why it took us 2 years to do this project. But next slide. Here's the final benthic habitat classification scheme, and it's divided into 3 levels. We mapped at level 2, where you can see the different reef habitats. We included the reef crest formations, as well as spur and groove, boulder and rocks. Those were all mapped individually, and this was done in consultation with coral reef experts and folks who have been partnering with the Nature Conservancy to develop this classification scheme that would best serve management purposes. It was a fine balance between what you could map and what you couldn't, and we had to do a lot of testing because of the limitations of the satellite. With only 3 visible bands, you could only map so much. You can't get down to species level mapping. The more classes that you introduce, the more chance you have of introducing error. And so we had to find a fine balance between what we thought was possible and we could do accurately and what the data could support. Next slide. Here's some examples of the benthic habitats that we've collected underwater videos across the Caribbean and some of what they look like. I'm sure many of you are familiar with these, and these have a unique spectral signature, and that spectral signature will change depending on your depth. And so we did a lot of testing. We tested a lot in St. Croix, in the Turks and Caicos, in Dominican Republic, by collecting a lot of field data at different depths of these habitats and trying to understand these patterns and how these spectral signatures change as you go deeper into the water. And we're not able to map deeper than about 30-meter depth, and that's under clear water conditions. So beyond that, we don't get any bottom reflectance. But this was very, very important to calibrate and to use as training data for the algorithm that we used for the Caribbean-wide mosaic. Next slide. Oh, here's some examples of some field data that were collected where we had cameras. We also used underwater videos, and all of this had to be tied to a precise GPS location. And so here's an example of the work that we were doing in Dominican Republic, where we had a very precise GPS, RTK, and it was linked with a camera underneath that antenna, and we were able to take pictures as we towed that bodyboard along with the boat, and this really helped us to get accurate representation of what was at each location and the habitat that was there. Next slide. And so let's talk about the classification. So we start with the surface reflectance. You can see there in A, this is an example for Turks and Caicos. We created a shallow ocean mask representing the shallow areas, and that was based on the geomorphic and also the satellite imagery, the geomorphic zones. And then we took the Dove data and we applied an adaptive filter, an adaptive algorithm that was able to extract the bathymetry. And the bathymetry was based on a light attenuation model, and the bathymetry was more accurate in the areas that were less than about 12 to 10 meters. And as you got deeper, the accuracy degraded. But we needed the depth to be able to identify things like patch reefs and use it in the classification process. It helped in the ecological rules for things like seagrass, where you know that seagrass, it's pretty rare to find it beyond 10 to 12 meter depth. It was used as a constraint in the classification algorithm. Let's go to the next slide. So here's the classification workflow. We had a parallel workflow, one for areas that were 12 meters and less, which used the depth and the RGB. And then for areas deeper, we only used the RGB values, the red, green, blue values. And these were processed in parallel and then finally combined. We split things up like dense and sparse seagrass and also hard bottom, dense and sparse algae. And we were able to break that up based on those RGB values in the imagery. The next slide. And we also developed, we worked with a group called the TAMA group, who's based out of Germany, and they are e-cognition experts. This was all done using object-based classification. And we developed a rule-based algorithm that used what we call parental guidance in guiding the classification. And you can see in A is the original image, and then in B, you can see the reef crest that was manually digitized in the geomorphic zone. And then in C, we applied this parental guidance algorithm that actually used, what we call seeding, which let the algorithm capture a certain spectral reflectance and then kind of bleed out into other areas based on a certain threshold. And so you can see that refinement of that fore reef and back reef boundary based on that process. It really helped improve the accuracy of the classification. Next slide. Here's an example of the final product for Turks and Caicos. You can see that 13 class. We're going to zoom into the area by Grace Bay in the north. The next slide. Where you can see the detail that we were able to achieve with the seagrasses in green, dense and sparse, and then the reef crest, what you see in that red, with the back and fore reef, and then picking up things like spur and groove. And these data sets are all available on the data portal. I don't know if many of you have been able to browse the data. We just uploaded a new version of Puerto Rico and USVI actually yesterday with some corrections that we had been sent. We want to thank anyone who provides these corrections. I'll talk about a feedback tool that we have because we want to continue to improve these maps. And Jimena just sent over the link there where you can get access to the maps. Let's go to the next slide. Here's an example of the tool. This is in Cuba, Jardina de la Reina, and you can see the distribution of these patch reefs, ones that were not picked up for areas like, using the millennial reef maps. You can see the detail. The reefs are in orange, and then we have the seagrass and the hard bottom extent. And in the tool, you can click on a certain area. You can also specify a buffer, and it will give you the amount of habitat based on your individual query. The next slide. And you can also visualize just the coral reefs. You can visualize just the seagrass habitats if you want to do that using this tool. This is all built in Google Earth Engine app. And then you can also download, and there's a link to learn more about the benthic habitats, the description of these habitats. It's all there. Next slide. And here's some examples showing the comparison between what was mapped on the left of your screen is what was mapped using the millennial reef maps, and on the right is what we mapped with the planet dove imagery. And you can see the differences where in some instances the millennial reef maps overestimate these reefs, and they miss a lot of patch reefs. So it's this system, this algorithm that was applied with the dove imagery was an automated method, but we spent about 6 months cleaning up any errors that we saw and fine-tuning and providing maps to experts to be able to give us feedback. And so it was very much a manual process, and we continue to improve on it based on feedback. Next slide. And so if you go to that Caribbean Marine Maps, this is the data portal. You click on the satellite imagery view, and then you can dive in and explore these maps. And if we have time, we can open it up and look at them. We'd love to get feedback from experts like you all who understand your reefs better than anyone else, and we want to continue to make those accuracy improvements. Next slide. Here's the data portal. You can see the distribution across the insular Caribbean, and then you can turn on individual layers and adjust the transparency. Next slide. Yeah, okay, we made it through. So that was kind of a whirlwind tour of 2 years of work, and we're excited to educate everyone about the maps and get them out into the hands of users where we can start to leverage and make progress towards protecting these habitats that we all care about. So with that, do you want to?
Thank you, Steve.
Yeah. We didn't want to do Q&A, or?
Yes, definitely. So I have shared with you in the chat the link to the portal that Steve has shown. I don't know, Steve, if you want to walk us through.
Yeah.
If you want to do that, you can do it right now. I just want to, before that, remind participants that you can put questions in the chat, and we will be taking after Steve walk us through the portal. You can also raise your hand, and by the end, I will give you the floor to ask your question. Yeah, go ahead, Steve, if you want.
Okay. Am I sharing?
You can share your screen. We haven't seen it yet.
Okay, you're seeing my desktop now.
No, yes, now we see it.
Okay, great. So I'm going to go ahead and load this up. And so here we have if you go to CaribbeanMarineMaps.org and you click on the satellite imagery maps, you can access the portal. This is where you can download the GIS layers. We want to find out who's using these layers, and so you just enter your name and why you're using them, so we can collect information about that. But yeah, all of these are available to download. And if you've already downloaded the Puerto Rico USVI maps in the past, I invite you to re-download, because we've done some updates. There were some errors that many folks pointed out, and we've corrected those errors and made improvements, and we updated it yesterday. So I just wanted to let you know. So here you can select on the different areas that you want. If you want to zoom into Puerto Rico, you can click on this, and then if you want to, you can visualize all the benthic habitats, or you can visualize the coral or the seagrass only. So this is looking at the coral. This is looking at the seagrass, and so we can zoom in. You need to hold down that control button to be able to zoom in, but we can have a look at these different habitats, and we would love to get more feedback in areas where we can make improvements. These are 13 classes that were done, and you can see that we've got Puerto Rico and US and British Virgin Islands are all together. But you can see if you zoom in these patch reefs around Anegada, they really come out, and they're not mapped in the Millennial Reef maps, which is much coarser, as we talked about. So You're able to set the transparency here and adjust it to be able to see through the image, but you're not seeing the dove imagery that we used to do the classification. This is obviously the Google Earth image base map, and sometimes that's not the best for looking through the water. So, we invite you to look at them, and then you can click on this little little button here to learn about how to provide feedback. There's a training video on how to do that. You can click on it here, or you can click on this and it will take you to an ArcGIS outline where you can actually select the area that you want, and you can actually digitize these. Let me go ahead and click on this. You have to click on edit, and there's this dove feedback polygon that you click on, and you can create polygons and add descriptions of the error, and that writes to a database that we can then download and make those corrections. So you can learn more how to do this by clicking on this training video, and it walks you through the steps of creating those feedback polygons that we can use to create the updates. So that's kind of a quick overview of the data portal. If you go ahead and do questions, answers.
Yes, hi. Perfect. So we have some questions coming up. And so, Steve, the first question is if these images were used after Maria. I imagine if they were taken after Maria. Can you talk a little bit about that? When is the time frame for these images?
Yes. The images were all collected after Maria. So Maria was in 2017, right? Yeah. So they were collected. There weren't many images before 2017. I mean, the planet Dove constellation was fairly small at that time, and they grew it over the years. But in 2017, there weren't a lot of images that were available. So most of these images, probably over 90%, were acquired about mid 2018 to 2019, the end of 2019. So they represent 2018 to 2019 images. So it does capture post Maria.
Perfect. Thank you, Steve. The next question is there any reason for the absence of data in the Secheo Island?
In where?
The Secheo Island. Please let me know if I'm mentioning it correctly.
Okay, now I need to be educated on where that is.
I don't know if the person that made the question is in the west end, the Secheo Island.
Okay,
Go ahead.
This is Stacy. I made that question. Hi, Steve. Nice presentation.
Hey.
Hi. No, I thought Mona didn't have data, but I just checked and it does have data. Desecheo is just north of Mona on the west side of Puerto Rico. It's a small little island off of Rincon. And I see that there's data missing from there. There are some shallow areas of Desecheo.
How deep is that area?
You have shallower areas like less than 30 meters that can be mapped. Most of the
Oh, you're talking about right in here.
Right here. Yep. Yeah.
Oh wow. Okay. Yeah. That's. I don't know why that was missed, but yeah, we do have Mona, and this is a very small island off Mona.
Monito.
Yeah.
Monito. Okay. But yeah, we don't have any data for this, so that's exactly the kind of feedback we need. But because I'll have to go check the image mosaic and make sure that we have that in our Dove mosaic, because yeah, that's we don't want to miss out on these little islands. Yeah, but you're exactly right. Thanks for pointing that out.
Thanks, Mip.
Thank you. All right, I'm gonna go ahead on the next question. Can you use these maps to find some coral clumps with algae?
Coral clumps with algae. Well, all of these, the footprint of these reefs. So this is a class called reef/algae, which is likely to be coral framework. There's live, and there's also rubble in these classes. It was hard to pick out, and so we kind of clumped it in this class. And this is the same class that the Allen Coral Atlas uses. But there's not a distinction between really healthy coral and coral that is covered with algae, because it was very hard. We just didn't have we tried to do that with the field data that we had, but it just didn't. Our accuracy was not that good. The quality of the satellite imagery did not support the discrimination between that, and so we decided just to lump it together, and hopefully with the super doves, where we have more bands, there's 8 bands in the next generation dove, we may be able to do that. We don't know, but this is the best we could do with the dove imagery.
Thank you, Steve. Just to let you know that whoever is raising their hands, I'm getting there. I'm just gonna do a couple of more questions on the chat, and we switch to the people that are raising your hands. The next question is, please send the link to update the maps by email. We can do that definitely. I have just grabbed the link and I'm putting it in the chat, but we can definitely send it by email, and like that you can have access to that link that Steve is showing there under download the GIS layers.
Yeah, right
like
there.
If you are a local expert, yeah, so you will be able to access through the portal, but we can also send it by email, and like that you can access it easier.
Yeah, and you can download the data and create polygons yourself with attributes if that's easier for you, and send those to us.
All right, one more on the chat, and then I will go ahead and give the floor and then go back to the chat. So the next question is from Ernesto, and it says, thank you, Steve, great work. Are you planning on correlating these maps with your previous work on coral spawning, settlement, and ocean circulation?
Well, we're actually using these maps in a project that Jimena is leading, and that's looking at coral climate refugia. So we're trying to identify areas in 4 countries that coral will more likely be able to withstand the impacts of climate change into the future, and put better management efforts on these areas. But in terms of connectivity, that would be a great application I did some regional connectivity modeling using the Millennial Reef maps about 5 years ago, and now that we have these maps, that's exactly the kind of modeling we want to look at, as well as ecosystem service modeling. These maps provide a consistent product across the whole Caribbean basin, so regional models really benefit from having these types of data. So that's the direction we want to move, is looking at improving those regional models.
Perfect. Thank you, Steve.
Anything you want to say to that, Jimena?
No, just yeah, for the coral climate refugia, we will be using the data from 2015, but the idea will be to update those regional models. But this, exactly what you said, this is the type of data we want: regional data that is consistent, and like that we can.
Yeah, but we are using these new maps for the actual coral area.
Exactly.
So yeah.
We will be using the maps for the coral climate refugia modeling, and that will give us a map for the entire region with prioritization sites that will be also available to share with you the results of that model. We hope to have that model maybe in 10 months or so. So more on that soon. All right, so Hector, I'm going to give you the floor if you can unmute yourself, please.
Yeah, I'm right here. Thank you. Hey, Steve, one question. You said that you mentioned that you compare the millennial reef maps with your maps. Were you able to compare the maps that NOAA have from Puerto Rico, the habitat maps that they have? In some area, they have like even like 93% accuracy, that they have gone back to the field to, you know, to
Yes.
collaborate the data. Have you been able to, you know, put those two together and see how far off or how far they are?
Yes, yes. No, that's a great point. We wanted to be consistent in the application since this was such a big area, and Puerto Rico has the luxury of having those maps that are more accurate. But that is not something that I've done yet, and I really want to do. And if there's someone in Puerto Rico I can work with to do that and use them to improve the accuracy. We only use the millennial reef maps to guide and to look at, you know, how we can improve across the whole insular Caribbean. So we want to look at you know, existing base maps and try to make some comparisons to see what the accuracy is. We're getting ready to submit an article that talks about the accuracy, but I don't have any field data from Puerto Rico. Most of the field data that I've collected has been in Turks and Caicos, Eastern Caribbean, Haiti, and so we did an accuracy assessment, and our overall accuracy assessment was about 76% based on those data sets, and that's when we combine hard bottom classes and the seagrass classes. We came up with an overall accuracy of about 76%. So, and that's what's going to go into the paper based on our field data. But we'd like to take data sets like what you're talking about that have been, you know, really refined and the accuracy improved and try to get a better sense of how these maps compare to those.
Yeah, that's great. And plus, you know, they have their areas too that they're unknown, that maybe your maps can, you know, fill those gaps too.
Yeah.
But I'm gonna be working on. I go and visit a lot of the south areas of Puerto Rico, so I'm gonna go into the tools for the expert, and I already saw some patchy areas there that I can maybe, you know, give you some extra data on it.
Oh, that'd be great. And what's the date on that data set you're talking about?
Although NOAA, they have been, that's a good question. I don't really know exactly, but you know, you can ask the people from DNR and maybe the NOAA people, and they will, because, you know, we keep going out into the field. They do like a national monitoring program every 2 years, and they use their map to send us to check out if, you know, to see the reef mostly, and when we go to the different points, we tell them, well, this is a reef, no, this is a seagrass, no, you missed, this is like mud. So they keep refining their mapping.
Yeah.
And they come and do like side scan sonar, and they keep, you know, improving their different map. But some areas, like I tell you, they're unknown, so maybe, you know, your data can fill those up.
Yeah, let's work collaboratively on this to try to get it better, because I know there's errors, and we need to you know, more field data and more expert knowledge will really advance this work.
Thank you. Thank you.
Thank you.
For me. All right.
So Steve, Hector, to follow up on your comments, we have William Hernandez saying we have collected field data and developed Benthic maps for some sites using commercial satellites like WorldView 3 and 4. And so he's very interested to talk about these. And then we have Tanya, the Puerto Rico coral reef monitoring data is publicly available online at the NCEI website. There are 42 permanent stations, 21 sites monitor every other year. So,
okay.
Just for your information. All right. So, Stacy, will you like to ask your question? And then I go back to the chat. Stacy, can you unmute yourself? Oh, you're not. You don't have your hand raised anymore. So good. The next question, well, in case Stacy wants to join, how many validation points were done for Puerto Rico? Do we have for Puerto Rico?
Yeah, we don't have any validation points. We haven't collected any. So what we did was we used several over 1,500 underwater surveys that had been collected in St. Croix, Dominican Republic, and Turks and Caicos. Those were the countries that we trained the algorithm on, and then that algorithm was applied to the whole insular Caribbean, and then followed up by manual corrections. So we don't have any field points for Puerto Rico. And in terms of the training data that was used, we just selected those 3 areas based on the resources that we had. Does that make sense?
Yeah.
Okay.
Okay, the next question I have is, how far do you think we are, I believe we are, from picking up bleaching and disease from remote sense data? Currently, we rely on SST abnormalities and predictions to identify potential bleaching hotspots.
Yeah, well, Greg Asner came out with a paper that work he's done in Hawaii, and he's getting very good at picking up this using the imaging spectrometer that he has on his global airborne observatory. So getting that from satellites is very difficult. I don't know if there's been any, not that I'm aware of, research that's been done using WorldView 3 imagery to be able to pick up bleaching. That's a very subtle. You've got to be able to, these pixels are basically what we call mixels. They're a combination of a lot of different features, and that bleaching signal is very hard to pick out unless it's very broad, and large patch reefs are bleaching. Then your success goes up. But as far as I know, we haven't been able to really coordinate that, because the satellite has a temporal resolution. We can only image it at certain times. There's a lag, and correlating that with actual field data. So there's issues to be worked out there. And the Dove satellite is nowhere near with the broad spectral bands that it has to be able to detect that. So you should read Greg Asner's Hawaii article that came out this year that talks about moving towards the ability to map the intensity of bleaching, and that's really the future. But it's going to take a while to be able to do that from space.
Thank you, Steve. One more here. How accurate the percentage of error are these maps? I think you talk a little bit about that accuracy assessment. And then it has, can they be used for construction planning purposes? Examples, construction of breakwaters, other Army Corps, or of engineering projects?
Well, I did talk about the accuracy earlier, where we just ran this for this article that we're submitting probably next week. But the accuracy was right around 76% based on the underwater field transects that we'd collected in areas outside of Turks and Caicos, Dominican Republic, and St. Croix. We took all the other field data sets that we'd collected over the years and used that to come up with an accuracy of 76%. So in terms of the second question was about construction, and I mean, this provides a, this is a regional product, so obviously you're going to have to, look at the areas that you're considering doing any kind of type of construction, and probably field validate these in more detail. But we really support the use of these data for things like nature-based solutions for adapting to climate change, and there's models that you can use to identify where are reefs going to provide more coastal protection benefits, and also there's areas like in the Dominican Republic where they're trying to determine why sand is being eroded at certain areas, and how can we construct artificial reefs and other gray solutions to be able to mitigate the erosion of sand. And so, yeah, these products, we want to move governments in that direction to use nature to be able to make their coast more resilient. And you have anything else you want to say about that, Jimena?
No, just as you said, these models have been used by colleagues in the academia, and also because of the interest of the insurance companies on modeling erosion in the Punta Cana area as a case study or a business case to identify how, like, the role of coral reefs to reduce erosion in beaches, which we know that is a huge issue for the tourism industry across the region. So
yeah.
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 But
okay.
yeah, like, and if, like, like we know that DARPA, for example, has a lot of interest right now in breakwaters and things like that. It all depends on the type of data you need for this type of planning purposes. We are happy to work with you to kind of walk you through some of the data and some of the uses we have done already. We have, for example, worked not specifically with these maps, but we have worked on criteria for restoration, outplanting, and other planning purposes. So depending on that, we can work with you through, like, the different criterias and adapt the products for your use.
Mm-hmm.
All right, so we have a couple of comments here. The NOAA Benthic maps for all of Puerto Rico were published in 2001. All the raw data is online. Then there is the yearly DNER coral monitoring, plus the NE Puerto Rico, I think 2015 Benthic mapping. And then we have someone from, yeah, go ahead.
The question, the difference between the 2001 and the 2015 Benthic mapping, is that for the same area?
That was Antares. It was a comment, but maybe Antares, can you provide more information about that?
Hi, can you hear me?
Yes. Thank you.
Apologies. So I mean, I was the Northeast project is one that I was one of the PIs for back in my days with no. Yeah. So I mean, the 2001 Benthic maps were carried out by ENCOS island-wide. Hector Ruiz mentioned them earlier, and typically, whenever any of us go in the water and maybe see a data point that the Benthic map maybe is not accurate, that's what he was mentioning. Usually then just to tell no and then help with the accuracy that way. Then for the Northeast, it was a project that we went more in depth in the area of the Northeast, obviously. Sorry for being redundant. And so we pretty much took the existing 2001 Benthic maps and then went into more detail. There were a lot of in-water, divers. Also in the deeper area, it was done with the Nancy Foster. So it does go into the deeper area, deep corals meaning. But yeah, so those are definitely, as I said, more accurate. All that metadata is online.
Yes.
If not, you can always contact the ENCOS folks. But I think that would be a great start in terms of for the ground truthing for Puerto Rico. Again, not all of them are truth, but for the Northeast, it's definitely more accurate than the 2001 ones. Okay,
well, thank you. Yeah, we do have the 2001, and I actually do have the Northeastern. I'm aware of those, but there's no island-wide product for 2015, right? It's just the Northeast.
Correct. It's just the Northeast because it was, a project that we were doing and has led to a lot of, other directions of NOAA now working more in terms of watershed protection in the Northeast.
Okay, great. Thank you for that.
Very welcome.
Thank you, Antares. All right, so I have one more comment here, and then I have another question. So I am based in St. Croix, and I'm excited to have access to these data and GIS layers. Thank you. That's Kyril Monroe. Thank you, Guy. We will also like to share with you that we have also additional data for St. Croix, and maybe I give the floor to Steve to share a little bit about St. Croix, and then you can access in the same portal. Steve? Do you want to share about GAO, or you want me to?
Oh, you can go ahead. Yeah.
Well, I think you can. So basically for St. Croix, we have also flew the Global Airborne Observatory. So in the same portal, you can have access to these maps. We have also created an outplanting tool on a Google Engine app where you can access this and have like different criteria to select sites. And so this is something we have done in the Dominican Republic and St. Croix, so you will have access to that. And yeah, like Celeste Jarvis, you heard from her at the beginning, is our USVI director, and please let us know if anything we can provide regarding St. Croix as well. All right. Oh, go ahead.
Oh yeah, I was just going to show if you go to the marine maps and you click on the airborne imagery, these are the areas that were flown in St. Croix, and this is data not from Dove satellite but from the imaging spectrometer in Greg's airborne observatory, and you can see this is 1 meter data, and this is derived depth, and then we also have things like live coral that was modeled. This is all available to browse and to download on the same website.
Thank you, Steve. Perfect. And then I have one last question here: is what is meant by dredged? And I'm not sure exactly.
Okay, so dredged, you can see where areas were dredged based on the satellite imagery. It's very distinct, and those are essentially muddy bottoms, but we wanted to try to get an area indication of how much dredging activity was going on, and so that was something that was not automatically detected. That was something that was manually interpreted from the imagery and digitized. So any dredge channels, or looking at access to ports and things like that, that was all grouped into the dredged class.
Perfect. Let us know if that was clear. And then you can also see the classes in the portal. There is an access to the definition of the classes right when you are on the map on the right side, I think. All right. Hector, I'm gonna your hand is raised. Please let me know if that's the case. Yeah, good. Yeah. Go ahead, please.
One more question. Once the expert give you the feedback on the maps, how long would it take to be incorporated in the maps? And are the maps going to be constantly updated?
Well, we're still, thanks for that question. We're thinking about the best process to do this, and we're thinking about, maybe every 6 months we gather the comments. If there's something urgent that needs to be done, you can notify us and we can try to get that through faster. But we're thinking of maybe every 6 months taking all the feedback, doing those edits, and then uploading a new version and sending out a notification to those that have downloaded it that there's something new available. But we're trying to figure out what our resources are going to be to support this, and to continue to update it. It'll depend on how much feedback we get, obviously. If we get a lot of feedback, we probably want to update it a little bit more often. So
okay, thank you.
Yeah, so we're trying to figure that out. But please contribute and add your comments. We'd really love to have them.
Perfect. All right, so we have a question. Can the outplanting tool be used for Puerto Rico for coral restoration?
Well, the outplanting tool is only based on where we have the imaging spectrometer data. So that's where we're actually able to detect % live coral. So right now we can only do it in Dominican Republic, in the southeastern area, and also in St. Croix. But until we convince Greg to bring his plane out and fly more data, we're unable to
and we find the funding.
Yeah.
Yeah. All right. I think we have still like 10 more minutes if you want to. Like we put plenty of time for questions and answers and discussion, as that was the idea, to have a closer engagement with you guys. But in the meantime, if you want other question or think of other questions, I would like to also share with you that we have created a remote sensing and mapping of coral reef conservation online course. This was done through the Reef Resilience Network. This is a self-paced course that you can take online. It's free. I'm going to put the link in the chat. This was developed with in collaboration with the Island Coral Atlas, National Geographic, the Nature Conservancy, Reef Resilience Network. So this course has 3 main lessons. The first lesson is about introduction to remote sensing. The second lesson is about how to use the Island Coral Atlas. And then the lesson 3 is about the Caribbean maps that we are presenting today. We are also going to be starting a mentor course where Steve is going to be giving part of that. That is starting on March 2nd and goes to March 23rd. So you can access this course with the link I'm going to provide you right now in the chat. And again, you can either take it whenever you want online, or you can also take the mentor course.
Well, the question that I was expecting never came up.
The Island Coral Atlas one?
Yeah.
Go ahead. Maybe you want to talk about that.
The question is, what is the difference between the Island Coral Atlas and these maps? And you know, the Island Coral Atlas, I know many of you are probably familiar with that. They are mapping all of the world's coral reefs using dove imagery. And we started this process together, and we wanted to create maps that were specifically created for our regional partners, and we had different classes that we wanted to map. We're using the same imagery, but the difference is we have different classes and we have a different technique. And our technique involves more manual refinement of these classes. The Island Coral Atlas maps were produced using automated methods, and you know, obviously they have a much bigger geography. They're trying to do this for the entire world, and they don't have the luxury of doing the manual corrections. And so the Island Coral Atlas is what they're calling level 4 maps, and these are level 5, which are a little bit more. It's the same resolution, but it's more detail and it's more manual intervention in making sure that we're getting the right footprint of these habitats. So that's the difference in a nutshell.
Thank you, Steve. So if there are not further questions, I would like to, Steve, give you the floor if you want to say anything else before we close, or Celeste, Alberto, if you want to share anything with the group before we wrap up.
Yeah, I mean, I just want to thank all the organizers and the opportunity to talk about these. Be on the lookout for that article. That it's a very lengthy article that we're finishing up, and it talks in detail of the process that we went through to create these maps. That's going to be submitted to the journal Remote Sensing, and so that should be out in a few months. But we encourage you to provide feedback and put these maps to use. We really want to see applications developed and support you as best we can in helping protect and restore these systems. But thank you.
Thank you, Steve. Celeste or Alberto, would you like to say something? I don't want to put you in the spot, but just in case, to wrap up.
Oh, thank you to Steve, and thank you to you, Jimena, and Tania, Ingrid, and Ashley from DNER for this opportunity to all of us. So thank you very much.
I'd also like to thank everyone, and I do know that we are actively using these maps in the Virgin Islands, and I hope to do so in the future.
Great. I hope to come down there and help you.
I hope to be able to travel soon. Thank you, everyone, for joining us today. We will be sharing the links, the different links to the portal, as well as to the tool where you can provide feedback, as well as the online course, all the links that we provided on the chat. We will also be sharing the recording, and then Steve, Celeste, Alberto, and Tanya from the DNER contact. Thank you so much for joining today.
Great, thank you.
Thank you.